Hi guys, today we're going to be learning about exponential functions, and this is not the first time you've seen these functions. You have seen them in Algebra 1, but I just want to remind you this is the general form of an exponential function, y equals a times b to the x. And it's very important that you remember, and we'll do this as I go through examples, that you don't multiply a times b and then raise it to the x power. If you remember PEMDAS states that you do parentheses first, then exponents, multiplication, division, addition, subtraction. So if you were going a times b, you'd be doing m, multiplication. But of course, e comes before m, so you should do b to the x first and then times it by a. But we'll see that as examples come around. Also want to let you know, growth, we consider this exponential growth when this b value is greater than 1, and it's considered decay when this b value is between 0 and 1. So not negative, but between 0 and 1. So smaller than 1, but bigger than 0, so positive. And again, we'll be talking about that in the future examples. All right, my first example here is I want to show you what an exponential function graph looks like. I will tell you that exponential functions are asymptotic. That's A-S-Y-M-T-T-O-T-I-C, asymptotic. An asymptote is an imaginary line that the graph approaches but never touches. And I will show you kind of what that looks like. Like in the previous example or lesson, or chapter I guess, because that was a different chapter, we have to learn what this kind of function looks like, and then we're going to start tweaking it. Flipping it over, shifting it left, right, up, down, just like we did in the last chapter with the radical functions. So we want to show you what this function looks like. Okay, so one of the things that you can do is make yourself a little t-table. And I'm just going to go ahead and put -2, -1, 0, 1, 2. You don't need 5 points, but for this very first example, I'm going to show you with 5 points, and then you can probably go to 3 points in the future. But this is going to mean that this is 2 to the -2 power. And I don't know if you remember or not, but when you have a negative exponent, you can make it positive by moving it to the bottom, which becomes 1 over 2 squared, and then that becomes 1/4. So when x is -2, we have 1/4. And then if we have, my eraser here, I'm going to need it today, because I don't have enough space for all of this. But then if we do 2 to the -1 power, again, we can move that to the bottom and make it positive to 2 to the 1 power, and that's 1/2. So we get, when x is -1, we get 1/2. And then when x is 0, you might remember from before that anything to the 0 power is 1. So when x is 0, y is 1. And then it gets really easy, because now we're plugging in 1. 2 to the 1 power is 2. Oops. Let's get my pen back. 2 to the 1 power is 2, and 1 to the 2 squared is 4. So what you see here is 1, 2, 4, and these are reciprocals of this. So the reciprocal of 2 is 1/2, reciprocal of 4 is 1/4. And now we're going to plot it. So we're going to have -1, -2, 0, we have 1, 2. Remember, this is the parent graph. That will change when this number is different, but, and then we're going to put here, we want to go all the way up to 4. So 1, 2, 3, 4. And so -2 is 1/4. So this is roughly 1/2. So 1/4 is right about here. So I put a little dot there. Might even have to put a different color there. -1 is 1/2. So right about there. And then when x is 0, it's 1. And then when you have 1, it's 2. And then at 2, you're all the way to 4. So what you will notice is this function starts off really slow. It's always increasing, but it starts off kind of slow, and then it just takes off. Okay? And as you get larger values of x, you will see that it just gets bigger and bigger and bigger really fast. Now the asymptote that I was talking about earlier is this imaginary line right here, the x-axis. This line is a line that's kind of like a barrier. The graph will never touch it, but it will get very, very close. So when you draw your graphs, you should never have that graph crossing this asymptote. Okay, so that takes care of that parent graph for you. And now we're going to do another one. This one is 3 times 2 to the x. And again, we can make a little table here, and we can do -2, -1, 0, 1, 2. And what's going to happen here is you've got 2 to the -2 power. We already know that when we have -2, 2 to the x is 1/4. And all I'm going to do is take that 1/4 and times it by 3, and that's going to be 3/4. And we know what 2 to the -1 power is. It's 1/2. And then 1/2 times 3 is 3/2. And then we know that 2 to the 0 power is 1 from here. And 1 times 3 is 3. And then we have 2 to the 1 power is 2. And 2 times 3 is 6. And then we have 2 squared is 4. And 4 times 3 is 12. And again, you can see how I'm going to graph this guy. We're still going to go -1. And actually what I want to do here is maybe make my x-axis a little bit longer. So, oops, give my pen back. We will do that. And maybe go down to here. We're going to have -2, +2, okay? So we're going to go maybe 2, 4, 6, 8, 10, maybe 12, okay? My last value is 12. So 2 all the way up to 12 is going to be up there. 1, 6, 1, 2, 4, 6 is going to be right there. 0, 3, 2, 3 is right in the middle. -1 and 3/2, so that's 1.5. So there's -1, -1.5. Oh, sorry. This is this is 2 actually, so this is 1. So 1.5 is right about there. So this is 1, 2. So 1.5 is right about here. Okay? And then -2 and 3/4. So here's -2, and this is 1, and this is a half. 3/4 is right about there. And then you can connect your graph. There we go. So again, you can see how it's asymptotic, approaching the x-axis but never crossing it. And that is how you graph exponential functions. And so now you can try these two on your own. And then we're going to go on to what happens when you put a negative in front of the function. Now again, these are the same two functions that I graphed earlier, only now it's -2 to the x and -3 times 2 to the x. So if the a value is negative, basically means that you're going to have an x-axis reflection. But I am going to show you how that works as I graph these functions here. So let me get my axis going here. Okay. Actually, ixnay that. I'm going to start off with my t-table because then that will determine how wide I make my x and y. So I'm going to go -2, -1, 0, 1, 2 again. And I'm going to put here -2 to the -2 power, which is -1/2 squared, which is now going to give me -1/4. So I'm going to put a -1/4 in there. Then we have -2 to the -1 power, and that's going to be -1/2 to the 1 power, so -1/2. So I'll put -1/2 here. Now keep in mind that this negative in front doesn't really affect the negative exponent. That's just the negative from here, okay? So then I'm going to put 2 to the 0 power, and that's going to be -1 times 1, because 2 to the 0 power is 1. So you're just going to get -1. And when I put 2 to the 1 power, it's going to be -2. And when I go 2 squared, it's going to be 4 times -1 is going to be -4. So if you're paying attention, and if you look at your notes from the other example I just did, then you have all the same y values, only instead of being positive, they're all negative. So we're going to graph that now. And since they're all negative, I don't really need a positive y-axis. So I'm going to make my, come on pen, Why aren't you drawing? Hello? Pen? Oh, there we go. And we'll undo, sorry about that. So I'll draw my y-axis like that, and I'm gonna make my x-axis, my y-axis a little bit longer because I want all these negative values. I want to go all the way down to -4. So -1, -2, -3, -4. I still have 1, -2, 1, +2, x, y. Okay, so when I plot this, I'm going to go -2 is down here, and -1/4, this is 1, this is 1/2, 1/4 is right about there. And so it's going to be maybe right here. And you can't really see it because it's black, but I'll make it red, there we go, right about there. -1 is -1/2, so that's going to be right smack in the middle there. And then 0 is -1, so -1. 1 is -2, so here's 1, and there's -2. And when x is 2, you're going to be all the way down here with -4. And then you can see why we call this an x-axis reflection. It's basically a mirror image from y equals +2 to the x. So it just flipped over on the x-axis. You can see from here, this was y equals 2 to the x, and now we've graphed -2 to the x. So it was just a nice little x-axis reflection there for you. So we expect that this graph will do much the same thing. So I have my little t-table, and I'm going to do my little cheater thing that I did earlier, which is I already know what -2 to the x is because I have all those values here. So all I have to do is take all those y values and multiply them by 3, not -3, because -2 to the x is these y values here. So I'm going to multiply by a +3 and then fill in my table over here. So -1/4 times 3, -3/4. -1/2 times 3, -3/2. And then we have -1 times 3 is -3. 1 times 3, sorry, I'm getting lost here. -3/4, -3/2, -3, and then -2 times 3 is -6. And then we have -12 because -4 times 3 is -12. So again, I make my table, all of my values are negative, so I don't need a very long y-axis, or at least I don't need a positive y-axis. I do need a negative axis, so I'm going to go ahead and do that. 1, 2, 1, 2, there's y, there's x, and we're going to go all the way to 12, so again we're going to go by 2's. So 2, 4, 6, 8, 10, I never make that quite long enough, huh? -12. Alright, so we're going to graph -2, -3/4 this time. And this is 2, so this is 1 right about here, and this is a half, so 3/4 is right about here. So I'm going to come over here, put my dot right there. And then we've got -1 and -3/2, which is -1.5. So that would be roughly right here. Why isn't it plotting? Oh, it's disconnected. Come on, come back. This doesn't count. Okay, there we go. So then we're going to be right about here. It's connected now. I don't know why it disconnected, but there it goes. And then we're going to have 0, -3, so that's right here. Remember, we're going by 2's. When x is 1, we're at -6, 2, 4, 6. And at 2, we're down at -12. And you can see how the graph is basically a reflection of the x-axis from the one that we did earlier. So you can also try the little trick that I showed you, because I want you to do these now, and these are the exact same graphs as the do-it-yourself number 1, only now they're negative. So you can do those. And then we want to talk about, we just did the x-axis reflection, so how do you get a y-axis reflection? Okay, a y-axis reflection happens when you have something like this. And you might be wondering, before, when you put a negative in front of the a, that flips it on the x-axis. So what you have to remember is that this can be written 24, we said that this is 1/2 or 1/2 to the 1 power. You can actually write 1/2 as 2 to the -1 power, because that would, to make it positive, you would flip it over to be 1/2. And then if you remember, a power raised to a power, you multiply. So 24 times 2 really to the negative x. So basically when you have a negative x, so the negative is now in front of the variable, not in front of the a, that's when you have a y-axis reflection. Or basically when this number in here is decay. We said that earlier, I talked about it earlier, that if the b value is greater than 1, which it was in the previous examples, then you have growth. But if you have a number in here that is less than 1 but bigger than 0, which 1/2 is, then you have a decay function. And decay, if this is what growth looks like, then decay is this direction. Okay? So what I want to do right now is actually graph that for you. Alrighty? So again, the first thing we're going to do is make a little t-table. Okay? And we're using, the 24 is a really big number. Okay? So I want to perhaps give you, sorry, I'm looking for my example here. I want to go same values from before. Just keep in mind that it's important, or it's beneficial sometimes for you to make your t-table first, because that will kind of determine how big you want to make your graph. So what happens with -2? Well, I'm going to get my little calculator over here. So we're going to go 24, and it's really important that when you're putting this in the calculator, that you put the 1/2 in parentheses. So 24, I use the multiplication button, parentheses, 1 divided by 2, close parentheses, and then I use a little caret key, which is that little guy, to raise it to the x power. So I use the variable button for that. Or sorry, I want to use -2 because that's what x is going to be. And I get 96. So you see, we're going to have a really big y value for that. So then we're going to do -1. So same thing, I'm going to go 24 times parentheses 1 divided by 2, close parentheses, raise it to the -1 power, and I get 48. Okay? And then we're going to put 0. Now it gets a little bit easier because we know that 1/2 to the 0 power, anything to the 0 power is 1, and 1 times 24 is 24. Okay? And then we have the 1 as the x, so I'm going to put 1/2 to the 1 power is 1/2, and 1/2 times 24 is 12. And then we're going to do 1/2 to the second power, which means you're going to square the 1 and square the 2, so you're going to get 1/4. And 1/4 times 24 is going to be 6. Okay? So that is what you get for your t-table. So now when I draw my graph, I don't need any negative y values, but I am going to need some really big y values. Okay? So I'm going to not make a very long y-axis into the... I'm not going to go very far into the negative area, but I am going to make this really big. And what you're going to want to do at this point is, it's not going to be exact because these numbers are really large, and that's okay, but it should still have more or less the right shape of an exponential. So what we're going to do is probably go all the way to 100. So we'll call this up here 100 because this is 96, which means that somewhere in the middle, if I can find the middle here, it's probably 50. Okay? And then right about here in the middle of 50 is probably 25. Right? And then halfway between 25, you can probably get, well, that's probably good enough. Alright? So again, it's not going to be exact, but I'll show you what I mean by good enough. Okay? So I want to plot this. -2 is 96. So -2, 96 is going to be way... This is 100, so you don't want to make it right at 100, but a little below 100. That's probably a good spot right there. And why didn't it right? I don't know. Let's see. 96. There we go. But I want it to be red, so there we go. There's roughly 96. -1 is 48. So -1, 48 is going to again be a little bit below the 50. So right about there. And then 0 is 24, a little below 25. Okay? And then 1 is 12, and I believe that half of 25 is 12.5, right? So this is about half, so it's going to be a little below that. So we'll put it right about there. And when x is 2, you're going to get 6. And half of 12 is, so you're basically right about here. Now again, this is a ballpark, but it's good enough. And When you have really big numbers, I suggest that you do it this way. Okay, but there you go. There's your graph. Notice the asymptote right here. It's not crossing the x-axis. By the way, that equation is y equals 0. The equation y equals 0 is a horizontal line going through 0 on the y-axis, which is basically the same thing as the x-axis. So another way of saying x-axis is the line y equals 0. So if they were to ask you what is the horizontal asymptote for this function, the answer would be y equals 0. Okay, but you can see that it's still asymptotic. It doesn't cross this line. And you can see how normally an exponential function would do this kind of thing. That's growth, right? Well, this is decay. You read a graph from left to right, and if you're going left to right, this is growth. Okay, this is decay. It's decreasing. All right? So that is basically what that graph looks like. So now we're going to have you try one on your own. Very similar to the one that I just did, but slightly different at the same time. Okay, and then we have this little guy. And this little guy is an example of how you can translate or move the graphs from one, what is it called, vertical shift, horizontal shift. So we know that this x minus 2 is going to shift the graph 2 units to the right, and the plus 4 is going to shift it 4 units up. So I want to graph that for you. And I'm going to use my little trick from before, from the last chapter. And that is that normally we start at -2, -2, -1, and so forth. So let's do that. But if I'm shifting 2 units to the, so let me just explain this to you because I don't want you to get confused. Normally, I pick -2, -1, 0, 1, and 2, correct? So right now, because this is x minus 2, it's going to shift the graph 2 units to the right. So this point is going to become 0. So I'm actually going to go 0, 1, 2, 3, 4. So instead of having these values, I'm going to have 0, 1, 2, 3, 4. Okay? So what you want to do is you can actually do this really easily by putting this into your calculator. I'm going to put it into the calculator so that I can do this a little bit faster. We're going to put in y equals 2 times, this is in my y equals menu in the calculator. I'm going to put in parentheses 1 divided by 3, close parentheses. I'm going to raise it, and I'm going to make sure that this power is in parentheses in my calculator. X minus 2, close parentheses, and then I'm going to put plus 4. And I'm going to graph it, and you can't really see, I know it looks really small, but I'm going to go to my table on my calculator, and it's telling me that when x is 0, y is 22, when x is 1, y is 10, when x is 2, y is 6, when x is 3, it's 4.66 repeating. And so basically 4 2/3. And when x is 4, it's 4.22 repeating. Okay? So I'm going to use those values to come over here and graph this function. Alrighty? So again, we have a bunch of positive values and not very many negative values. So I'm just going to go ahead and do this. So we're going to go -1, -2. +1, +2, and then we're going to go by maybe 5s. 5, 10, 15, 20, 25. So when I go 0, it's going to be at 22. So that's probably right about maybe here somewhere. 1 is 10, so 5, 10. 2 is 6, so 5, maybe a little above 6. And then we got to go to 3. And 4. When x is 3, we're 4.6, so a little below the 5 mark. And at 4, we're 4.2, so a little below that. And when you connect those dots together, like so, you get your graph. And what you will see now is that your asymptote is actually going to be the 4. It's going to shift. This is now your asymptote. It's never going to cross the y equals 4 line. This guy right here. So your asymptote is y equals 4 because the graph shifted 2 units to the right and 4 units up. So that is what you graph that one like. And there's that guy for you. And this is our last example. And so this is how do you write an exponential function of this form when they give you 2 points. It's actually not that hard to do. What you want to do is plug these, this is x and y. So you basically want to pick one of the points, start with one of them, and plug it into x and y in here. So since that says y is 2, we're going to say 2 equals a times b to the 2 power because x is also 2. And then at that point, I could just solve for a by dividing by b squared. And so a equals 2 over b squared, which seems kind of weird, right? But just leave it there for a moment, and then come over here and do it again with the other point. In this case, y is 4, so I say 4 equals a times b to the 3rd power because this time x is 3. Well, since I already know that a is 2 over b squared, I can now plug that in for a. 2 over b squared times the b cubed, so this is a, b cubed, and then equals 4. So what's going to happen with, you can combine these. So these b squareds cancel out 2 of those, leaving you only 1. And you have 4 equals 2b. Divide by 2, and b equals 2. So now you know that b equals 2, and you come back over here, and that means that a is equal to 2 divided by 2 squared, which is 2 over 4, which is 1/2. Not really sure why my pen's not working. I'm running out of time here. Hello? I'm really sorry about this. I have no idea why my pen's not working. Well, anyway, I don't want to waste my time trying to figure out what's going on with this pen. I'm not really sure why it's not working. But the point is, I'm just going to finish it like this. Oh, there we go. It's responding. Let's see if this works here. There we go. So we've got, yes, move now. Thank you. 2 over 4. Why isn't it writing? Okay, now it's connected, but it's still not writing. Okay, so I'm done with that, but we're almost done, so I'm just going to go ahead and tell you that b is 2, and I'm going to go ahead and use my marker over here. This is 2 over 4, which is basically 1/2. So we know that the answer is y equals a. A is 1/2 times b, which is 2 to the x power, and that would be your equation. I'm not really sure if I can change the screen here for you because the pen is not working. So I will tell you right now that the example that you're supposed to be doing is the exact same thing that it says here, but the 2 points that you'll be using are 2, 4, 2, 4, and 3, 16. 2, 4, and 3, 16. And once you have done that, you will have completed this lesson. So I will see you in class.